Starting with an empty project, first thing we're going to do is create a 2D scene, name it main, and add a canvas layer. So that to this we can add a bunch of UI elements that the user will interact with to connect to the other user. I'm going to create a label and name it port number, and I'm going to duplicate this label a couple times with Control D for our other labels. Next one we'll call output, next one we'll write as enter message, and the final one will be for the IP address. We'll cover some of what these things are later, but for now the only one that we actually need to change the name of is the output. We'll call it output label so that we can refer to it by name later in our code. Next we're going to have to add a few line edits. This is a place where the user can enter in text and numbers, and we'll make one for the message, the IP address, and the port number. These likewise we'll refer to in code by name, so names do matter. So we'll call them message input, IP address input, and port number input. Alright, the last thing that we need for the user interface is a button, so that once the user has finished entering all the information, they can click on this button to start connecting with their peer. So we'll name it Start Connecting and put the text Start Connecting on it. We'll go ahead and save the scene, and we can go ahead and add a script to it. The first thing that we're going to need in our script is a reference to all the different named elements, our labels and line edits. So we'll go ahead and grab those. But we'll also need a few extra variables in addition to this. Message as bytes we'll explain later, but that's going to be a packed byte array. We'll also need a peer, which is going to be a packet peer UDP. We'll also need a variable for the port number, and that's just an int. And we'll also need something for the IP address of our peer, and that can be a string. Alright, the last thing that we're going to need is a variable to keep track of whether we are currently trying to connect or not, and that is just going to be a bool. Alright, clicking on the button, we can go ahead and get the trigger for when it is being pressed, and go ahead and connect that to this function on start connecting pressed. A few things need to happen when we press that button, and pretty much it involves just grabbing the information written in by the user. So we're going to take whatever message is in our message input and turn it into bytes rather than text. We're going to grab the port number that was entered and turn that into an integer. And we're going to do the same thing with the IP address, but it's already a string, so we'll just keep it as it is. And then we're going to create a new peer, or packet peer UDP, and use some of that information in setting it up. So we're going to bind it to the port number that we chose. That's the local IP address or local port number that's going to be used. And then we need to set up the destination address, which involves our peer's IP address, and we're just going to use that same port number. It could be different, and if you're running it locally on the same machine, it does need to be different, but for this, we'll just keep it the same. And finally, we'll set connecting to true. All right, inside our process function, we're going to check if we're connecting. If it's not, we're not going to do anything, but if it is, then we're going to go ahead and add our message in bytes to our peer. So essentially send a message to the person we're trying to connect to. And after sending that message, we're going to check if we have any packets available to us. If we do, we're going to go ahead and change the text of our output label to whatever the message we've been sent. So we used var to bytes to turn the message into bytes, and we'll use bytes to var to get that message as text. All right, we're going to go ahead and enable multiple instances so we can have 2 locally running instances of this scene. And we can go ahead and enter some information. I've been using port number 60,000. I don't think it really gets used by anything, but there's a Wikipedia page if you want to make your own choice. And then because these are both on the same machine, we're going to use localhost. We're going to go ahead and enter hi and hello as the 2 messages, but you'll notice that it is just showing up on the left one, both of them. It's flickering between the 2. This is because I'm using the same port number on both, so it doesn't actually know which one it should be sending to. So both of these instances are sending their message to just the one on the left. This wouldn't be happening if you're actually running it on 2 separate machines. And for testing purposes in my other project, I just switch out the port number on one of them so that it knows which instance it should be sending to. First of all, I want to address the fact that I put localhost here rather than an actual IP address. I do that just so I can show both users on the same computer, but you would actually put an IP address here of the person you want to connect to, using local IPv4 addresses if you're on the same network, or IPv6 addresses if you're on separate networks, like someone else in a different part of the world. There are two main benefits to using this method of multiplayer over anything else. The first one being that it doesn't require you to host a server. No dedicated server, no small handshake server. It's just two people connecting their computers. This is great for a couple of reasons. One, it means you don't have to pay for a server or host a server yourself. To implement multiplayer, you can just implement multiplayer for free, the same way that you would a single player game. And it also means that you don't have to keep anything going for other people to play your game. You can make a game and forget about it, and 20 years later people can still be playing that game because there's no servers or anything like that you have to maintain. The other benefit of this method over other ones is that it doesn't require you to mess with your router in any way. There are other methods to doing peer-to-peer multiplayer without any servers, but they usually require someone to access their router and turn some settings on, most famously port forwarding. The main downside to that is that, let's be honest, most people don't know how to access the router, and even if they do, they might not be able to or knowledgeable on how to actually set up port forwarding. It's a pretty big barrier to ask someone to overcome to play your game. All that being said, there is one major issue with this method. It kind of requires you to have an IPv6. You might not know what that is or whether you have one, but you can find out by going to many different websites. The one I use is whatismyipaddress.com. If it lists an IPv6 address for you, then you have one. Well done, you can use this method, assuming the person you want to connect to also has an IPv6. If you don't have one though, chances are you can probably ask your ISP for one, or you might just need to enable it on your router. While this method could work on IPv4, because we ran out of IPv4 addresses a while ago, and for reasons that I'm not going to get into in this video, you would have to randomly guess your peer's port number. I did get this working with IPv4, just looping over the last 20,000 possible port numbers, and eventually after a couple hours it happened to align and I got a connection on IPv4. That's not ideal though, so you kind of need IPv6 for this. With all that out of the way, let me explain how this actually works. Alright, let's say we have your computer over here. Here's my little monitor with the tower next to it, and here is my little router sending out fun little signals, and say here's the person's computer that I'm trying to connect to. The monitor, give them a little router to connect to the internet. What happens is when we have a packet we would like to send, we kind of send that to our router. So this might be the message hi from our example before. That's going to find its way through the internet wherever it takes, get to this router, and that router is not going to send it to this computer. Why is it not going to send it to this computer? Well, this computer over here never requested anything from your computer, and it's going to essentially be like, well, this wasn't requested, I'm going to just like block it right here. And so this computer will never even know that this message was trying to be sent to it. It got stopped and it never got passed through. It's only going to pass through information to this computer if this computer requested for it. At least that's just probably by default how your router and computer is going to be set up, which makes it very hard to communicate with each other, right? You need to be sent a request, or a request needs to be sent to you for you to then be able to send a message back to them. Well, how this works is with something called punch-through, often referred to as NAT punch-through, but technically this isn't a NAT, this is just, I guess firewall punch-through would be what you could call this. But essentially what happens is, yes, I'm sending this message hi, but at the same time, you'll be sending a message in the other direction. Let's maybe go with the message bye. That message will also be sent through the internet, whatever path it takes, to this router. And once again, on my computer, I didn't ask for that message, and so routers on both sides will just block that message and be like, nope, not passing that through. But if we have a look at the code, I don't just send a message once, right? It's in the process function. That means every single frame, I'm checking again, I'm putting another packet here. I'm listening for another packet. I'm putting another packet, listening to another packet. So yes, my message hi goes through, gets blocked. Your message bye goes through, gets blocked. But then I'm going to send another one, right? I'm going to send another message that says hi. I'll put it up here. In this message, says hi again. Nothing's changed about it. It still goes through the internet. Nothing's changed about it. But now if we have a look at what the other person's router sees, it sees that I sent out a message that said bye, and I was sending it to this computer over here with its IP address. And a moment later, I got a response, and it came from that computer, and it's sending it to this computer. So I should let this through, right? I put out a message saying bye, and now I'm getting a response of hi. And so it actually lets through the message saying hi. And same thing happens over here when we send out a second bye message. It gets sent through the internet, it comes over here, and likewise, it saw that we sent out a message to this computer over here, and now we're receiving a message back from that computer that we sent a message to, and so it lets it through, and bye gets through. And now that we have, in both directions, sent a message and successfully received a message from the other person, we now have a connection. And as long as these messages, or a message, is being sent somewhat frequently between the computers, then we will have a connection, and it will keep that connection. Because whenever we receive something, it knows that we were requesting information, so it's going to let information be sent to us. It's just the initial handshake that requires this kind of back and forth failure to get through because it wasn't requested, and then the second one was requested, and so it does get through. Now, this at least gets initial handshake set up, and you could continue to add to this and write code that passes packets to your peer and listens to your peer and receives those packets. However, what I do in the project I'm currently working on is at this point I pass it along to the built-in multiplayer of Godot. All right, so in my personal project where I use this, you might see some familiar stuff with the onStart connecting button pressed and the if is connecting. However, here I'm not having a message for you to write in, but I have some pre-defined messages for kind of a back and forth between the host and the client for, whether they've started, whether they've confirmed that everything's set up on their end. But it works the same way to make that connection. But then what happens after, I think, 5 seconds, just to make sure that there is a good connection, is I actually closed down that peer connection. And the reason why I closed that peer connection is so that over here I can create a new peer, but this peer is using the eNet multiplayer peer as opposed to just a packet peer. And this allows me to use kind of the built-in Godot multiplayer, and I can pass it off to that to handle most of the stuff. I still need to use some RPC calls for updating certain values, but for the most part, I can just pass everything over to the built-in multiplayer that Godot offers, and it will handle things like making sure things are spawned in on both players' computers and update their positions and that sort of thing. So I essentially, on both sides, once that connection is made, I close that peer and create a new peer on that same port. I might not have to close that other peer if I just used a different port number for this connection, but I found if I left that previous peer open when I tried to create this port or create this peer, it would fail. So that's why I close it over here before doing that. If you'd like to test it out, make sure that I'm not lying about how this works. Here on itch, I have something called multiplayer test. You can run the game in the browser, but I have found, or I believe, that the eNet multiplayer peer does not work when you're running it in browser. That has to be something like running on a exe, something like that. So while you could play the solo version of this in the browser, to actually test out the multiplayer, you'd both have to download the exe and the PCK.